Workbench for big data analytics on Hadoop. And I want to give you a little bit of background on pervasive software, which is the company I work for. Probably most of you have not heard about them, so just a little bit of background on that. Talk about the history of DataRush. DataRush is the framework that we've been working on for several years. It's very scalable, it's very fast, built for data processing. It's built on dataflow, so we'll cover dataflow concept real fast. Talk about why we kind of integrated with Hadoop and kind of how that came about. I thought it was important to give you a little bit of history of kind of how we got to where we are today. Do a little bit of a demo and talk about some performance testing that we've done recently. Okay, Pervasive is a global, is a public company, it's PBSW, so if you want to go look us up on Yahoo financials, we're there. A couple of things that we do, you may have heard of B-Tree, eSQL, it's a very old embedded database that's been around forever. It's still around and we still produce it. Also data integrators, one of our major products. We have a cloud group that brings all that onto the cloud. And then the big data analytics and big data and analytics group that I work in. So when we first started on DataRush, we really built it to be a next generation data engine for our data integrator product suite. And so the requirements were to be, for it to be a very high data throughput engine. Very scalable. At the time, we were really focused more on multi-core, not really focused on multi-node at the time, but also very data scalable. We want, had lots of customers that had lots of data that they needed to process. It's based on dataflow. We knew that was something that we could build on top of, and felt very confident in its ability to be, being a component-based framework. It's very extensible. It's very easy to, very flexible. It's very easy to add to, and it really fits very well inside of a visual environment. So we actually embedded it within a couple of data pervasive products, one called Data Profiler, when we started integrating into Data Integrator also. And we just thought it was a good, broad kind of base framework, and so we built an SDK on top of it and started looking for some other ways to use it. We actually kind of spun off from our CTO group into our own division and started working on other applications for it. So just a kind of data flow concepts in general. Think about a directed acyclic graph. Within the graph, the nodes look like head down the bottom, I have kind of an example. The nodes themselves are actually doing the work. They transform the data in some sort of way. So all the data is just flowing across these data flow queues. They read the data, they transform it, they push it downstream. It's very much a shared nothing architecture, so it's very easy to program in. You don't have to worry about synchronization. You don't have to worry about thread management. All of that's handled for you by the framework. The data just flows along the edges, so it's very much a pipeline architecture. So if you look at the example, this filter rows node, for example, it's reading in a chunk of data. It does its job. It pushes its results out onto its output queues. It reads the next chunk of data. So you can see as that goes along, the pipeline fills up, and that really gives you very good pipeline scalability. But it also supports other forms of data parallelism. Very, very easy to do horizontal type of partitioning within Dataflow also. And it's very data scalable. So, this pipeline can handle 1 million rows of data or 1 million rows of data. It really doesn't matter to it. It might take a little longer to do 1 million than 1 million, but it should handle it. There's no constraints on how much data it can handle. So if you look at this kind of logical graph at the top here, this is the user thinking about what it is they want to do with the data. And so they don't really have to think about how that's going to be accomplished. And so, for example, it's just reading some data, doing a filter, applying the predicate filter, right, doing a derived field, just doing a calculation of some fields. It's grouping the data, so it's doing some sort of aggregation, and then just writing the results out. So very simple. But what happens underneath the covers is that actually gets that logical graph, that kind of logical view of what the user wants to do is compiled down into a set of physical graphs. So for example, if you look at this, we broke this down into a 4-way parallelism. And we're reading the data, filtering, doing the derived fields, doing a little bit of the grouping up front, and then we had to split the job in two. So we have the second phase and redistributes the data by that partition, keys of the group, does the final grouping, and then writes the data out. All that's done in parallel. And the end user is using this visual framework to build this out. They didn't have to think about how that was going to be done, whether it runs on one machine or multiple machines. They just really have to worry about what it is that they're trying to accomplish with the data. And then underneath the covers, a lot of this technology is being applied to optimize that as much as possible and make it run very fast and very scalable. Just a snapshot of our operating library. join these operators, provide some function on data, for example, of course, I/O. Then we have different types of analytics that we build, like association rule mining, different classifiers for doing predictive analytics, clustering, gamings, and linear and logistic regression, and then a whole slew of transformations that you can apply to your data. Because as you know, when you're doing data analysis, a big part of that is having to prep the data before you can actually do the analysis. So we have an ETL background, that's part of where our company comes from, and so that's part of our focus also. Data Explorer, we're doing this data discovery, and then data matching, this is all based on fuzzy matching. So it's the ability to bring together disparate data sets where you can't do exact matching, you have to do some sort of fuzzy matching to figure out data that's the same. Okay, so a little bit of left turn here. So 9 is an open source workflow analytics tool. You can find it at 9.org. It's the desktop tool itself is open source like this, so you can download and start using it. They also have some enterprise features in there. They call it team space and server. These are for collaborating and a large team of people that want to collaborate together using this desktop tool. And they also have a report option. We looked at this tool a few years ago and really like it. It's based on Eclipse, so it's a really easy, extendable type of framework. It's very easy to build a plugin and extend the capability. And so we were looking for a GUI tool, we were thinking about building one ourselves, and when we found this, we thought, well, let's just integrate with it. And so we integrated Data Rush as an executor, just built it as a plugin, as an extension into 9. And we also added all of our Data Rush operators, so all that functionality is available also. And we call that Rush Analytics for 9, so that's the marketing name for it. So, bringing all this together, 9 is actually a pretty interesting environment because it has extensions for like R, so if you like writing R scripts and you're using that tool, you're very comfortable with it, you can use it within 9 also. So you have the visual part of 9, but you can also do R analysis also. It integrates with, you can use SAS data, you can use SPSS data, it has visualization pieces, so it's a really nice environment for doing data analysis and data prep. And then when you add the Data Rush engine in there, then it becomes very fast and very scalable. And then also we can integrate that with Hadoop, so that allows you to use this visual workbench within a cluster and be able to run this from your desktop and be able to do kind of drag and drop design of your workflows. So all this was kind of going on in parallel with Hadoop being developed. So at some point, a lot of our customers, because we generally work with probably mid-sized customers, some very large customers also, and so they weren't really worried about big data for a while. And as Hadoop became more popular, they started having more big data problems. They started coming to us and saying, we like the framework, but we wanted to work with Hadoop. And so we started looking at how do we integrate. And the first level was just at the data level. And so we integrated with HDFS. We built up a nice file system abstraction within our framework. And so that way, all of our I/O operators that can file I/O, they just work very seamlessly with it. It actually has distributed execution, and so we're using splits very much like MapReduce does. And so when you go to read a file or read a bunch of files, we'll split it up into chunks and we'll do locality optimization, so that when we're on the nodes within a Hadoop cluster, we're trying to read the data as close to where it really exists. We also integrate with HBase. We have a lot of scenarios where we're capturing time-based events, CDR data, or NetFlow type data. And so we use HBase as our temporal store. And we've actually built a very fast loader for HBase using H-files directly. So that way we can write directly into H-files, formatted in encoding that we use, and then we can read the data back very quickly. But when we actually execute within the Hadoop cluster directly. So we're not just reading the data from Hadoop via HDFS, running our jobs on a single machine and then pushing the results back out. We're actually running within the Hadoop cluster itself. And we actually started work on making Data Rush multi-node even before we started integrating with Hadoop. And so, Hadoop having that distributed file system, it was just a great fit for what we do. And we are integrating with Yarn. And I know Arun from Artworks, we've been talking with him about it for about a year now, and some other projects came up and kind of pushed it off. We're actually starting to do that work now. And what that will way of doing resource scheduling within a Hadoop cluster, so that MapReduce jobs and other type of applications running on Hadoop can actually share resources. So that way you don't overtask your machines. And so then the data rush can play very nicely with your MapReduce job and you can share resources. So this is kind of the layout for us doing distributed execution. And again, we started work on this before we started integrating with Hadoop, so you can see a little bit of probably analysis type of functionality. So as a client, when you actually run a job, it's going to run on a cluster. It talks to our cluster manager. And that cluster manager is like the kind of general resource manager for the cluster. It also has a performance monitor, which is web-based. So that way you can see what jobs are running, you can kill a job if you want to. You can do management on those within the cluster. You can look at log files. Just kind of like a nice log monitoring and management console. So the cluster manager, when it starts a job, it then talks to all the node managers running on the actual working nodes and says, okay, I want you to run this job for me. And then it spawns what we call an executor. That fragment executor then actually runs that part of the job that it's responsible for. And sourcing data from HDFS is then going to read the data through the local data node. And what we'll try to do, we do the locality optimization, so it's going to try to read only data that's on that node. Sometimes it may have to read data across the network, but we definitely try to minimize that. And then as the job is running, stats are coming back through the cluster manager, and actually, I'll show you on the visual environment. You can actually see those stats as it's happening. And so it gives you instant feedback into how your job is doing. As I mentioned before, we distributed I/O, and the way that looks with a data rush, we would have like one node or one operator that would just assign splits. So it says, okay, you want to read this group of files, and then you have hundreds of files within a directory. It's going to look at it's going to get all the information from HDFS about the files. It's going to split it up into individual blocks, and then it's going to send that information to all the workers on the actual data nodes and tell them which splits it wants them to read. And so that information gets sent out, and then all the I/O is happening in parallel. And then all the workers downstream, all the other nodes or operators downstream that are doing the work, they just in an area to run in parallel. And we use the same concept where the graphics run locally, it's just run on a single machine, or it's run on the cluster. And so that way, when you build operators within our framework, you don't have to worry about that. It's the same way it's local or distributed. Okay, we can do a quick demo for you. So this is the 9 GUI that we integrated with. This is our Rush Analytics product. And you can see it's very much like it if you used it before. So you have these workflow projects here. Sorry, this is getting squeezed down. And this is just a way of kind of organizing your work. Down here you have all the nodes that you can use, and the idea then is you just drag and drop them onto the canvas, you link them together, you can set properties on them, and then you can run them. This one is actually going to run here on my machine, so let me just crank this up real quick. And so what I'm doing here is I'm actually reading some retail data. I'm going to do missing value, replace missing values on it, because I know that some of the data is actually null. I just want to throw those rows out. We're doing a group here, because I know that some of the data was repeated, and so I wanted to remove the duplicate rows. And then I'm running that big row on it. And this is an association rule mining algorithm. So it's looking for, it's usually used in market basket analysis, where you're looking for some sort of association between items. Items that sell well together, items that lift other items into the basket. And those are the sorts of things that retailers are very interested in. We also support EML, which is a predictive model market language. And this is a standard that's built by the data management, data mining group. It's kind of a consortium of companies that come together and define this standard. And so we output the actual association model within that format. And this model converter is actually reading that EML model, and it's converting it into GATF format, and that's used for like network visualization. So we integrate with a network visualization tool called Yahoo, and that can actually then be used to see, kind of help you see all the associations between all the products. The nice thing about being integrated with Yahoo is you can do things like you support different views. So each node that you build can have its own view. So this is just a tabular view of these association models. So here I see all my frequent item sets, I can see all my association rules, but I can also then build kind of more graphical views of that also. So this is just taking all the association rules and graphing their support versus their confidence, and then the size of the bubble is the lift. And then I can just fly over one of those and I can actually see the rule itself. And these are just SKUs, so it doesn't really make a lot of sense, there's numbers. But if you knew what the SKUs were, it would, it'd be very meaningful to see these rules. So this was just running on my desktop. And, but as I said before, we did have integration with Hadoop. And I'm just going to run a video to show you what that looks like. Okay, let's see it. So down here we have a view, which is actually the cluster. So you can see we have a 3-node cluster, and that data rush is running on. And so I can see I have 3 node managers. I'm actually then looking at the data that's the limited text reader is reading. And you can see the data is coming from HDFS. And so within this visual environment, you can just actually browse data on HDFS. You don't have to kind of know where it is, right? You can just browse through the directory structure. Like you would normally do, and then pick this up. This is milestone data. It's actually generated data that's part of a benchmark. It has spy fields in it, and an ID, a timestamp, a site ID, a compromise field, and an indie ID. And so we're just going to do a very simple workflow. This is actually one of the, it's called an E10 benchmark, where we do a date value extraction. We pull out the year, the week of the year, from the timestamp field, we then group by site ID and year and week, and we're doing a count of the number of events that happen and a sum of the number of data events that happen. We're then sorting by the site year and week and storing those results back into HDFS. So a very simple workflow that's using this data, but good for a demo. But actually, we've seen customers build these workflows with 40, 50, 60 nodes in them. Pretty complex stuff. All right, so we actually configured this workflow to run on the cluster, and sorry, so the videos have to kind of wait for it to catch up. And it will just hit go, and what's going to happen is this will actually then run on the cluster. We can see the data going by as it runs. So a little bit of setup time, and then we'll see that the processes are actually running on the cluster. So those are the ones that we just kicked off. And if there are other jobs running there, we would be able to see those also, so we have some sense of how busy the cluster is. And like we were saying before with dataflow, you can see those numbers increasing, these nodes working together, data just kind of flowing in that pipeline between them. Group is having to do that final group, right? So you're not seeing data come out of it until the group is done. But while this is running, we also have another view here, the graphics details view. And I can actually drill down into individual operators. I can drill down into an instance of that operator or one of those. On each node, we're going to run multiple streams on that node, so you can actually then see each of those streams. And that's really useful. Actually, the other day, we came out with a new release, and someone had changed one of the operators. They didn't realize they had kind of induced a performance problem. And we ran one of these demos, and something that used to run in a minute took about 5 minutes. And I couldn't figure out what was going on, so I actually ran it, opened up that view, and then was able to figure out, oh, okay, I see this one operator is taking up a whole lot of CPU time where it shouldn't be, so what's going on? So actually, this view was able to be very useful in kind of figuring out what that problem was. Doing distributed programming is hard enough. You need these kind of tools, kind of performance and profiling and debugging tools to help you figure out what's going on. So we try to be really good about that as far as that capability. Okay, one of our customers, a big data rush customer of ours, they started to use Hadoop. The group that they were working with actually uses Pig quite often, and they were trying to decide, should we use data rush, should we use Pig, when should we use one, when should we use the other? And so they wanted us to do kind of a bake-off to see, given some data, how did the two perform. And so we use TDCH data. It's actually benchmark data from the TDC. What's that? Transaction people who do the database benchmarking. So it's a really nice data set because it's retail data. I think it's about eight different data sets. And they have a data generator, so it's very standard, very common type of data to use. So we generated a terabyte of data in HDFS, and then we generated we wrote several of these queries using DataRush, and then we wrote them using data. Actually, they were already available. I don't remember where we got them from, but they were already available in the data, so we didn't actually have to write the data scripts. But we did look at the scripts just to make sure that they were doing the right thing, and they were being very efficient about it. So then we ran these tests on our 5-node cluster. It's 5 worker nodes, it's 16 cores per node, 64 gigabytes of RAM on each of the nodes, and 24 1 terabyte disks on each node. So pretty meaty cluster, but not too much bigger than what I think is fairly normal. And you can see the results. The results for DataRush are in red, the results for Pig are in blue, and that shows you the runtime in seconds. So it's small runtime, of course, is better. So some of the queries, like query 1, we were about 5x performance is Pig. Other queries were 2 to 3 to 4x. On query 6, we were kind of neck and neck. So it just depended on the query and what type of work was being done. But in general, we were showing really good performance. And I think part of that is just being based on dataflow. We're able to do some things a little more efficiently, maybe not make too many passes over the data. And so that allows us to be a little more efficient. But you can see kind of head-to-head competition. In general, at least on these queries, we have really good performance. Doesn't mean every time we're going to be faster than it did. But for the tests that we've done, we've shown some good performance. Okay, so who's using this? Opera Solution is probably one of our biggest customers. If you don't know Opera Solutions, they're a data science solutions provider. So they do large consulting jobs. And they are embedding DataRush technology in their engineering solutions today. Within healthcare, we have a customer of ours that's doing claims processing. They use DataRush to do all their claims cleansing and pre-processing of the data before they get into some of the analytics that they built. We're hoping to get them to actually rebuild their analytics in DataRush also. That was really interesting because they were using another product to do the cleansing. It was taking hours. We went in, we did a POC with them, and within a day, we had it running in minutes. And they were just really ecstatic with that because it's just allowed them to take on bigger customers. Within retail, I'll show you a little bit of market basket analysis. We have a full solution that we're working on in that space. And we have a couple of customers lined up for that now. Telecom, we did a POC with CDR data. CDR data is just a great fit for this type of processing. And we're kind of still in the sales process with that customer. But we were able to make their processing much faster. And we did a much lower granularity of analysis of their data than they were able to do before. And this is just a quote from the chief operating officer at the time of Opera Solutions. And one thing we really like about what he said is just the scalability, right? It kind of supports their vision of running on single servers, running on Hadoop clusters, because they don't always, their customers are not always using Hadoop yet, but they want to be ready for it when they do. But they are running with a lot of customers today who are using Hadoop, so they need an answer to that. And they like that they have one answer that scales that host spectrum. Okay, so in summary, this Workbench is a very easy development tool for building Hadoop workflows. We really focus on just making this as easy as possible. You don't have to write a lot of code, so you can see that this is very simple, but we've seen customers do fairly complex workflows using this tool. And again, they didn't have to write a lot of code, they didn't have to know how, they don't really even have to know how MapReduce works. We're not using MapReduce. They don't have to know how really Hadoop works, but they just know that the data's there and they know what they want to do. Very scalable execution, executes within the Hadoop cluster itself, so we're not just pulling the data out and pushing it out and pushing it back in. We're actually running embedded within the Hadoop cluster and taking advantage of those resources. And it has very small, very large data sizes, and as we showed with the TPCH performance test, it scaled up really well against Pig. And when we ran that test with Pig, we also ran a 3 terabyte test. And what was really interesting, of course, the runtimes were longer, but the ratios were very similar. And that showed that both products scaled really well as with more data. They didn't run slower or they didn't run faster than we thought. They ran about exactly. If it was 3 times more data, the runtime performance is exactly 3 times more. We ran it on a 3-node cluster and on a 5-node the 5-month cluster, we just see much better time as you would expect. Okay, here's my contact info. You can email me, or I'm on Twitter also. And there's our website. You can open the website and check it out. And definitely email me if you're interested in taking a look at this, or you just want to ask a couple more questions, and I'll take questions then.
Questions there?
Thanks for the presentation. Just want to ask, so is your product similar to like the R package for accessing Hadoop with RHDFS or RMR? Is there similarities to those? Those R packages still, you're not in the backend run the MapReduce job, enable user to use the R like. I'm just wondering if there an analogy or.
Yeah, there's probably an analogy in the sense of, they're taking the R library and enabled it to run Hadoop. I think the difference would be, like all of our algorithms, or any of our operators, are built to be distributed. So they're built to be parallelized. And so that's kind of where we start. Of course, I think the R part, I don't know that much about the R integration. But my understanding is that they haven't taken the core R library and parallelized it. You're able to actually invoke R functions on your data. Distributed within Hadoop, but the R functions themselves are not parallelized. So you kind of have to manage the parallelization a bit. And again, I'm not fully up on this, I may be incorrect, but when I looked at it, I guess about a year ago, I saw I presented that at one of the conferences, and that's what it looked like. So similar, but I would say different in the way we approach it.
Thank you, Jim. On one of the slides, you showed some queries for data for Hadoop functionalities or split. Of all the queries, how many queries were better? I know you only showed a few rows of data. And the other question is, what do you attribute to your performance over big in the investment goals of your architecture? Can you comment a little bit on that?
Sure. So I think we were better on at least there are 22 PPC queries. These are the only ones we ran. So we haven't run all the queries. I think we picked these originally because these are known to be maybe the harder queries or the more time-consuming queries. We could go back and do all of them. Of the ones we ran, data rush was faster than they did all of them. Now, the amount was different. Right? So you can see on query 1, we were about 5 times faster on query 6, and maybe 20% faster. So what we attribute that to, like I was saying before, I think it's being based on the dataflow. We're able to do probably more with data than MapReduce. MapReduce is really great at a lot of things, but it is limited in what you can do. Right? So within a map and MapReduce, those are only 2 things that you can do. And so with dataflow, I think we're able to do kind of more with the data and optimize in that sense and not hit the disk as much. We really only have to hit the disk when we redistribute the data. Your application is different than it is currently, or you need a different sort order, whatever that may be. We may have to redistribute the data, but we try to be very optimal in how we do it. So I think that's the part.
How does the tool handles the skew in the data? Like, I've seen a bunch of examples where it's very hard to kind of see how the data will come in, and so how do you say that the tool can handle the skew data? So if everything is going to one reducer.
Yeah, so one thing that you can do with our data explorer, it just provides a bunch of descriptive statistics that you're able to use. And so I've always used that first to look at the data, so then you can kind of discover where those skews are and think about that as you design your workflow. But we can run into those same type of problems that I do. If you partition your data on a key and the keys are imbalanced, that can